Hello, everyone. My name is Tim Kratek. I'm a founder of Ironside and have been an architect in the BI and data space for over 25 years. My colleague Jeff Spear and I, Jeff leads our information and data practice, will cover many of the concepts that we're going to talk about today. Here is a high-level agenda. We'll give you a quick overview of Ironside, a conversation around the analytic framework summary, talk about what's actually in reality today from the perspective of many of our customers, framework overview, and then a reference architecture. I also want to welcome everyone that has been attending our Take30 series, as well as others that are joining for the first time. We appreciate your participation and engagement, as well as input on the topics we are covering via this series. As we get started here, I want to provide a brief overview of Ironside's scope of capabilities. Our main goal is to help our clients use data to inform decisions and improve outcomes in their business. How do we do that? Clearly, it begins with strategy. Oftentimes, decisions are made based upon industry reference models, but at Ironside, we believe strongly in a use case-driven model. We believe data and analytics strategy should be clearly aligned with business strategy, and we have proven methods to derive and align those things. Design and architecture is the second component of our service delivery offerings. Tool choices, rationalization, cloud and data platform design, data models, data catalogs, all are critical aspects to get the appropriate information to the business constituents at the right time. Of course, we have a delivery team focused on executing on above design, leveraging best-in-class tools and capabilities for storage, integration, and delivery, whether it be via dashboard, machine learning algorithm, or a simple crosstab report. We've got capabilities around deployment, platform installation, migration and lifecycle, as well as version management. We have a managed service practice to support an end-to-end lifecycle of environments, tools, and usage. And lastly, a governance practice where we can advise on processes and methodologies which allow our clients to manage and work with all aspects of their data and analytics deployments. Now, getting to the topic at hand. We intend to today provide an overview of the Ironside point of view related to a modern analytics framework. Clearly, many of our customers have existing data marts, warehouses, operational data stores, as well as a number of other legacy data concepts. We believe that those investments can be leveraged and modernized to better and more efficiently provide data within the enterprise. We believe that a shift to a centralized, scalable, and adaptable framework will provide a stronger basis to inform the use case-driven model I've discussed previously, as well as support the ever-evolving needs of our customers. Typically, this will be deployed on a cloud platform to take advantage of developing technologies, microservices, Kubernetes containers, as well as cost-efficient architectures, which will essentially separate compute from storage for cost efficiencies. There are many aspects to this modern analytics framework, both in terms of storage, staging, movement, availability, and delivery of data. Some of these technologies are currently well understood and used in the marketplace, while others are evolving. Our view is that the knowledge and sophistications of the users of these enterprise technologies are growing and evolving, and their demands are growing and evolving. So from a centralized perspective, we need to provide availability, access, organization, and tooling to constituents. I hope this and subsequent sessions will provide a deeper look into aspects of this evolution. As always, we are available to meet and discuss aspects of these concepts with you directly, as we understand that each company has a unique set of priorities and challenges to evolve to a more mature data and analytics maturity. With that, I'm going to hand off to Jeff Spear to take you through more details around these concepts.
Thank you, Tim, and good morning, everyone. And also thank you for joining us on the first of this series happening on Thursday morning. We'll be conducting the rest of these Tuesday mornings, and we'll have some timing stuff at the end. So I want to start by talking about today's data reality. And that reality is that there's just more and more and more data available. Within existing systems are generating more data than before. New data sources are coming in, both within the organization and externally. And generally speaking, there's just a massive flood of data that is hitting the enterprise. with that data, we're seeing many, many more methods of analyzing and manipulating it. There's many more tools, there's many more techniques, there's different kinds of coding, different types of analytic tools. Just the number of ways that you can come at the problem of analyzing your data has grown tremendously. So with that, as Tim mentioned, data warehouses are alive and well and still very useful and providing a purpose, as is ad hoc reporting. Everything from ad hoc tools like Tableau or Power BI to we're analyzing stuff with Excel, Microsoft Access, and many types of solutions in between. With that, we're seeing that machine learning is being integrated at multiple levels. People are using it directly to build models and make predictions and improve their analytics. But many of the tools are using machine learning as well, so that you're sort of indirectly getting its benefits as you use certain analytic methods. With all of this proliferation, a one-size-fits-all solution, or even two sizes fit all, is no longer the answer. With more people exploring, creating, and deriving insight from data, you really need to leverage the full breadth of your data community to get all the insights that you can, and therefore all the value that you can from your data. So we think about sort of the high-level points of our modern analytics framework. The first point is the why. We want to identify known business analytic value. What value are you getting from the data assets that you have now? You want to be able to identify new data sources, new uses for existing data sources, and bring them into your data environment. You want to make sure that you are enabling your population of knowledge workers. You understand who they are, you understand what they do, you understand what their needs are to make them as efficient as possible. And you want to do that by creating a methodology that lets them generate new insights as efficiently, as quickly as possible, so that the more insights that they produce, the more value that you're going to see from your data. So we're going to be going into detail on all of these in future weeks, weeks 2 through 5, and then sort of giving a summary and bring it all together in week 6. Today we're talking about sort of the high-level framework. We're going to touch on all of these things, but understand that obviously we're going to go into a lot more detail on each of them in future weeks. So if we think about the 3 layers of a modern analytics framework, you really have rapid generation of insight through iteration, data as a service, and automated value delivery. So at the top, you have your knowledge workers who are going through this process of they bring data in, it turns into an insight, and we'll talk on the next slide about how that happens. They assess the value of that insight, and then they deploy it so that people can leverage that insight, act on it, and create value. And so in the middle is data as a service. And so the data in your organization is going to exist in many formats, anything from a raw data lake to a refined data warehouse, and many points in between. The important thing is that when an insight that provides lasting value is identified, that it is pushed back into that environment in the appropriate way so that the value delivery can be automated. Too often what we see is the people who generate the insights present the insight, and then they're told, great, please keep producing that insight and keep maintaining it. And depending on the tools that they use, often that maintenance is very manual and very time consuming and ends up taking away from the time that they could be spending producing more insights. And so overall, you see sort of, that value continues to exist, but you don't see the value grow. And so by making sure that the deployment goes back into sort of the automated data environment, that maximizes the value from that insight as well as from future insights. So let's talk a bit about insight generation and iteration. This is the cycle that a knowledge worker is going to go through when they are creating an insight. And this is an iterative process. So, they're going to sort of go through these steps, and at any point they might say, oh, okay, this isn't what I want, I need to go back. So the first thing that they're going to do is identify the data that they need. They're going to search all the assets that are out there that could solve the problem or question that they're facing. And so with more and more data becoming available, that search is becoming more and more difficult. It may be that they look for data and don't find what they need, or they find something that they think it's what they need, but maybe it doesn't have all the data, or the quality is not high enough, or there's an extra piece that could make it much easier. So being able to understand what data is out there and what they need to solve a problem is increasingly important, increasingly difficult in today's data environment. They then, having brought in the data, they need to understand what the data is, what the quality is, what they need to do to turn it into the insight that they want. Then they perform transformation. So they join data sets together, or they aggregate, or they perform feature engineering to create new fields or new calculations. This is the part where sort of the raw data becomes something more finished. Having done that, they can look at it, look for trends, look for insights, and then deploy it, and then send it back out so that people who are making the decisions can leverage that data. So this is the process. Anyone who's creating an insight goes through this process. Whether they're doing it in Excel, whether they're doing it with Cognos, whether they're doing it with Power BI, these are the steps that they're going to take. The idea is that you want to make sure that all of these steps are as simple and optimized as possible, so that knowledge workers can iterate through these steps, frequently, rapidly, efficiently, to find insights. The more insights they find, they're going to find the insights that have lasting business value, and those can be propagated across the enterprise. So that's insight generation. So I want to talk a little bit about data as a service, and I want to start by talking about data lakes. Data lakes are very popular. They're very important, and a lot of people talk about, I want to make sure all of our data is in a data lake. This is a quote from James Dixon of Pentejo. This is the quote that coined the term data lake, and it's a great metaphor. He sort of compares data marts and data warehouses to to bottled, packaged, prepared water versus a data lake of a natural lake. And it's a great metaphor because in a pure data lake, data just flows in. In a lake, you don't have to do much to get water in a lake. It just comes in naturally. But to get data out of the lake, as this quote illustrates, you have to take samples. You have to dive in. There's work involved. Getting value out of the lake takes a lot more work than getting data into the lake. And so that's an important point, because a data lake is useful because it has as much data as possible from the organization. And to get that data, you want to make it as easy as possible to put data into it. But that raw data may not be easy to analyze, and so it's easy to get data in. It may not be so easy to get insights out. And that compares to data warehouses, sort of as illustrated on this diagram. So if you think about a data warehouse, it's a lot more work to get data into a data warehouse. You have to understand your use cases. You have to create a data model. You have to build ETL or ELT to populate it. There's a lot more work that goes into building a data warehouse. But that work pays off because it is very easy then to get data out of the warehouse. You have everything organized into dimensions and facts. You can do drag and drop reporting. It's much easier to derive insight from your warehouse because of all the work that you put in creating it. And so these two data structures are sort of at the ends of a spectrum. And an important aspect of the analytics framework is that they're not the only points. So what organizations need to do is to create sort of different data zones that are in between those two. So for example, perhaps you have 3 ordering systems in your organization. And so in the data lake, there's 3 files or tables that have each of those order sources. And they're probably in slightly different formats, and maybe the orders mean slightly different things, and they're just not well aligned. A data scientist might say, great, that's exactly what I want. I want the raw data. I want to know exactly how it came in so I can do my modeling, and they're very happy. A business user might say, well, that's not super useful to me. I have to do a lot of work to bring those together. Is there some way that I can just see all the orders? So it might make sense in that case to create a data zone where the orders are combined into a single table, and some basic work is done to sort of align the columns and things that aren't common or omitted or put on the side. And basically, so a business user can say, great, here's all the orders, and now I can load that into Power BI or Tableau and do some analysis. So there's some work to create that, but it's not as much work as putting it in the warehouse. So for a little bit of work, you're getting a lot of value. It might be that there are some other users who say, well, okay, that's all right, but what I really want is sort of a big flat table with everything. I want orders, I want customers, I want part numbers, sort of all in one place, and then I can really go to town with this data. And for the tool that they're using, that is an optimal structure. So you do a little bit more work to create that table, and that gives them some value. And so what you're doing here is creating a set of different ways of structuring data that balance the cost to sort of implement and maintain with the ease of use and ability to pull data out. And so what's important to note is that there is no set of, you need X number of zones and here's a level of complexity for each. It's going to vary based on your organization, what kind of data you have, who your knowledge workers are, what they do, their skill sets, what tools they use. And so understanding that is critical to optimizing the return from your analytic investment. And then thirdly, if we talk about automated deployment, this is a conceptual architecture that sort of goes through what this would all look like at a high level. So a lot of this is very similar to diagrams that you've probably seen. You've got various types of source and external data at the bottom. It's automated either in batch or real time to sort of replicate into a staging area, and then it's via ETL or ELT. You're going to do some sort of if you're doing any master data work, it's done there, and then it's brought into your warehouse and other zones so that it is available for all the different ways that people want to look at data: self-service BI, enterprise, machine learning, data wrangling. It becomes available for all of them. The important difference is that in addition to the data warehouse on the right, you have all of these different zones. You have the unstructured zone in the lower left, which is really sort of the pure data lake. But you might have, okay, I'm going to put some features in for the data scientists. I'm going to put in some tabular data for people who need a little bit more structure. I'm going to put in some flat models for certain types of analytic users. So you are creating and maintaining all of those zones and letting people manipulate and use the data that you want. That creates the need for additional security. It creates the need for elastic storage. And this is often why we promote cloud storage for these zones, because people are going to want to spin up different things in different ways, and they probably want to have sandboxes to experiment with the data. And so being able to sort of increase and decrease your workload is super important. And so as Tim said, separating storage and compute is a great way to efficiently enable all of these zones. And so the zones in this diagram are an example. You may have you may need all 4 of these, you may need 2 of them, you may need 2 of these plus 2 other ones, depending on your knowledge workers and your data and how you can best extract value. And so then the last thing that's very important here is the data, an individual piece of data is going to show up in potentially all of these zones. So it's very important that the data be kept consistent, and that people understand that, okay, if I'm looking for orders, there may be orders in 5 places. Which orders do I need? And that really emphasizes the need for a data catalog, so that you can not only sort of know, what data is where, but know more information about that data. Here's the order data in its raw state. Here's the order data in its fully refined state. Here's the order data that's just been flattened out, so you can easily do some basic analytics on it. So being able to sort of understand what your assets are, where they are, and maintain that. So it's a tool is often of help here, but without the right people and processes to support that, the tool isn't going to solve all your problems. Those are sort of the 3 basic components of the analytics framework. Making sure that you generate insights as quickly as possible, having data as a service to make data available at the right level, and automating that data delivery into a data as a service layer, so that sort of separating the value generation from the insight generation. So we think about the benefits of a modern analytics framework. It enables you to focus on business value by generating insights as quickly as possible. Not every insight leads to lasting business value, so the more that you generate, the more business value you're going to discover. It automates the process of refreshing and maintaining analytics processes. That means that people are freed up to do more work on insights. It also means that you're able to deliver data to a wider distribution in ways that each audience can most easily consume. It means that you're able to more quickly ingest new data sources, which are becoming available every day. And it also ensures that you balance development effort with ease of consumption. You don't necessarily want to build everything into your data warehouse. That is a lot of work, and some of the data in there may not be giving you value. You want to put the high value data in the high effort place and sort of create a balance for data that is sort of in the middle. And that's going to change over time. So you need to be able to be flexible and change your designs over time. We're going to go to questions. We have the questions window, so feel free to type in any questions that you may have. And Tim and I will do our best to answer them.
Terrific. Jeff, while the audience attendees are putting in a couple questions, I have a few of my own.
Okay.
So you talked about the why. How do I identify known business value for new data sources?
So for new data sources, that's a good question. We're going to talk next week about identifying value for existing data sources. When new data sources come in, you're going to have to go through this insight process to see, where the value is. And so that's why it's especially important to make sure that you have people who are able to do that, especially people who are able to do it with the data sources before you've really done much to them, because you get a new data source and you're not going to spend a lot of time refining it until you understand what value it has. So it's really a question of identifying and enabling sort of your knowledge workers who are capable of handling, sort of new raw data and generating insights quickly, so that you can identify, prioritize those insights, and then say, okay, here's what we need to do with this data in order to make it more useful to a broader audience.
Thank you. I think the next question everyone will be able to resonate with. What's wrong with using Excel to explore data? Isn't that what everybody does?
It is, unfortunately, everybody does. And I mean, Excel gets a bad name not because it's a bad tool for analyzing data, but because it's a bad tool for automating that analysis. And so what we see all the time is, someone, needs to do analysis. They bring in a file from one place and a table from one place, and they put it in Excel, and they combine it, and they do macros and other manual stuff with it, and they produce, a great pivot or a great chart. And everyone says, great, send that to the executive team every week or every day or every month. And then that person is then stuck with doing that manual refresh every day, every week, every month. And over time, it tends to get harder because it gets more complicated. There are more copies of it. We go to places where the one Excel spreadsheet became 100, and someone is spending a week every month refreshing them all. So Excel is great to start, but what you need to do is then say, okay, this is valuable. Let's move it into, the warehouse or a data zone where we can automate it and let that person find the next big insight. There are tools that make that initial analysis a bit easier and make the process of automating it a bit easier, like data wrangling tools like Trifacta. But Excel is a fine tool for doing that as long as you sort of know when to let go.
Thank you. And going back to the why and the business value, one of our participants asked, what is the process or the framework to quantify our ROI of new data sources?
That's a good question. I think it's going to vary, obviously, based on the data sources and the nature of the insights that you're generating. Sometimes it's very easy, if you're looking at, we're working with a client on lead generation, so it's relatively easy to sort of say, okay, well, here's what our pipeline looked like before, and here's the amount we can credit to this new lead generation process, so we can, put a number on it. Or if it's a question of operational efficiency, or cost savings, we work with a client that did, sort of fraud modeling, so you can easily say, oh, well, we've identified X more fraud and saved X dollars. But sometimes it's definitely going to be more subjective. If you are enabling an executive to make better decisions, sometimes those decisions, you can easily put a number on it, sometimes you can't. And so, we have a couple different ways of doing that assessment, and it's going to vary, again, based on, the nature of the insight.
Jeff, if I may add to that, I think that, the the baseline maturity of the organization is a contributing factor. The number of business decisions and constituents in the business that see relative value in the addition of the new data source is a contributing factor. I think that, as Jeff mentioned, depending upon how structured and how, pulling a new source into a data lake is a fairly easy thing to do, and then, the sort of the users of that data will have to do the work to conform and to combine with existing enterprise data sources. Obviously, there's more effort and energy to put it into more of a structured model like a data mart, and combine that on a sort of an automated, repeatable basis. And again, these are all sort of considerations that come into play as we think through, what is the prioritization of adding additional content to an enterprise data store, and then what's the impact, what's the business impact, what's the value. So there is a process to do that, but again, the inputs to that process are, technology decisions, technology availability, resource availability, complexity of enterprise data model, et cetera, et cetera.
Yeah, and I did want to emphasize what Tim just said about, if you have a data lake and you have a method of getting data into that data lake easily, that lowers the investment side, right? It makes it very easy to bring in these new data sources and find the value, so that, the net ROI is going to be higher.
And Jeff, if I may just go back to your prior question about Excel, I think Excel is a great tool to model, experiment, discover. I think there are a number of other technologies, either BI or analytic technologies that can be used to automate and deploy and distribute on a repeatable basis the insights that are gleaned from that sort of Excel exploration, if you would. And I think that great tool for figuring out what is the answer, what's the methodology to come up with the answer. There are other tools that are more sophisticated in actually providing that on an automated, repeatable basis. So, again, that's about a maturity. It's about having a process. I think Jeff talked a little bit about that. To take content from sort of a discovery model where it's answering the question that one person has to being able to deliver and deploy it to many people, because it's an insight that's really important in the business, and that more people would want to see the outcome, even if they're not capable of figuring out what that analysis is in the first place.
Thank you. Can either of you share how cloud fits into this overall framework?
Yeah, Jeff, I'll take that. I mean, I think that cloud is a really broad concept, and obviously cloud migrations and sort of digital business transformation are concepts that are broad and far-reaching. I think as it relates to data and analytics, the cloud vendors and the cloud platforms often provide tools and technology that enable each of these different processes. The other part of it is, you're able to manage your costs more effectively if you pay attention and do it properly. We've certainly seen cloud costs get spun out of control without proper care and feeding. So, a cloud architecture is scalable to meet demands of the business. But again, there's been a significant amount of investment in, as I mentioned, microservices architectures, as well as, K8s or containerized architectures to support the appropriate processing, costing, storage, delivery. There's a lot there, right? And we'll probably spend some time in the future talking about that. But cloud is an enabler to make this transformation easier and more cost-effective and more user-friendly. That would be sort of my summary to your question, Debbie.
Yeah, the only thing I would add is it's much more incremental, so it makes it very easy to grow gradually, as opposed to, I've got to buy a whole new server or a whole new SAN because I exceeded my disk space.
Terrific. So we are at the bottom of the half hour, and so thank you for joining us for Take 30. Jeff, I'll let you close it out. I just wanted to remind everybody that I put in the chat window the registration for Tuesday's Take30 series, which will be where the remainder of the 5 weeks on the who, what, why, how will be covered. So hope you can join us, and the sessions will also be recorded if you're not able to make each one in the series.
Yep, that was the key thing I wanted to say is don't forget to switch to Tuesday starting next week. But also we've got a series coming up on Thursday. So next week we'll have something on Cognitive Analytics 1117 and a variety of other topics as well. So hope to see you next week on Thursday, but on Tuesday morning as well. And thanks very much for being here.